Welcome to today's tutorial about Gaussian elimination, linear algebra. Today we are going to discuss the following question. Here we're given a system of linear equations and we have to solve the system of linear equations by Gaussian elimination, express the general solution of the system, find three different points that are solutions of this system, and check whether your second point is indeed a solution of the given system of equations. Let's go ahead and get started. Okay, so I've written down the system of linear equations and we will solve the given linear system by representing it with the augmented matrix and bringing the matrix to reduced row echelon form by using elementary row operations. So at first, now we'll write down the augmented matrix of the given system. So here we have, for the first equation here, we have 1 actually. If there is nothing, it means 1x1 here, and 1x2, 1x3, 1x4. So if we write it in the augmented matrix form, we'll have here 1. For the first row, we have all 1s. And here we have a 1, which is this one here. Now for the second row, we have 3, and then we have a 1 for x2, x3 is 4, x4 is 6. So here we'll have 3, 1, 4, 6, and then for the vector v, we have here 4. Now, for the third row, we have here 4 for x1, 3 for x2. For x3, we have nothing here, so we'll write just 0. And for x4, it's 1x4, so it will be 1 here. And then for vector b, we have 2. So, writing down the augmented matrix, it's clear. Now let's go ahead and start working with the augmented matrix and reduce it to row echelon. So our augmented matrix looks like this here. We have 1, 1, 1, 1. And then we have here 3, 1, 4, 6. And here we have 4, 3, 0, 1, 2. Now what we're supposed to do to reduce this to row echelon form is that we will use elementary row operations. So first, let us multiply -3 to row 1, and that will give us the matrix here, which is -3, -3, -3, and -3 here, and also -3 here. And here we'll have the rows as it was. So here we have 3, 1, 4, 6, 4, 4, 3, 0, 1, 2. Now the next row operation that we'll do is, what's our target? What are we doing to make it into the row echelon form? What we're trying to do here is that we're trying to make all these elements below here 2 zeros, right? So now we have multiplied -3 to row 1. What we're going to do next is we will do the row operation. That's row, sorry. We'll take row 1 plus row 2. So we'll add row 1 and row 2 and put the values to row 2. So that instead of this 3 here, we get 0. So now here we'll have, so as row 2 is the only one that's changing, row 1 will remain as it is. So we have here minus 3, minus 3, minus 3, and minus 3 again. Here minus 3. So now for row 2, what we're doing is we're adding row 1 plus row 2 and putting the values to row 2. So row 1 here is minus 3 plus row 2, which is 3. So minus 3 plus 3 is 0. And then we have here minus 3 plus 1 is minus 2. Minus 3 plus 4 is 1. And minus 3 plus 6 is 3. Then we have minus 3 plus 4. That's 1. And there are no changes to row 3, so it remains as it is, which is 4, 3, 0, 1, 2. Now the next step that we'll do is that we will multiply 4 over 3 to row 1. So what we get now is that we get here minus 4, minus 4, minus 4, minus 4 here, and minus 4 here too. And then we'll get the row 2 and row 3 doesn't change. So we have it 0, minus 2, 1, 3, 1. And then we have 4, 3, 0, 1, and 2. The next row operation that we need to do to make this element here to 0 is we'll take now row 1 plus row 3 and we'll put the values to row 3. So what we get here now is row 1 doesn't change here. So minus 4, minus 4, minus 4, and minus 4, and minus 4 here. Row 2 remains as it is, which is 0, minus 2, 1, 3, 1. And row 3 changes here. So we have row 1 plus row 3. And we'll put the values to row 3 here. So row 1 is minus 4, row 3 is 4, minus 4 plus 4 is 0. And then we have minus 4 plus 3 is minus 1. Minus 4 plus 0 is minus 4. Minus 4 plus 1 is minus 3. And minus 4 plus 2 is minus 2. Okay. Now here, the next row operation that we'll do is we will multiply minus 1, 4 over 4 times row 1. And also we'll do at the same time minus 1 over 2 times row 2. So that will give us here, so row 1, if we multiply it with minus 1 over 4, 4 and 4 will get cancelled and minus and minus sign will get cancelled. So what we have left is 1, and that will be same for all of the values here because they're all the same values. So here you will have 1, 1, 1, 1, and 1 again. And for row 2, we'll multiply it with minus 1 half. So with 0, if you multiply, you get a 0 here with minus 2. If you multiply, so minus 2 times 1 half is 1. And then we have 1 times minus 1/2 is minus 1/2, and 3 times minus 1/2 is minus 3/2. And here we have 1 times minus 1/2 is minus 1/2. And then what we do is we write the row 3 as it is, which is 0, minus 1, minus 4, minus 3, and minus 2. The next row operation that we do is, now we'll take the value of row 2 and we'll add it to row 3 and we'll put the values to row 3. Okay, that's because we want to make this element here now 0. So we have for the first row all ones, and for the second row also there are no changes. So we have 0, 1, minus half, minus 3/2, minus half. And then for row 3 now, we'll be adding row 2 with row 3. So that will give us the value here 0, and 1 minus 1 is 0. We have 1 minus 4. Sorry, not 1 minus 4, but minus 1/2 minus 4, which is minus 9/2. And here we have again minus 9/2. And then here we have minus 5/2. So now here we come to the last row operations. That is, now we will multiply 2 times row 2 and we will multiply 2 to row 3. So here we have all ones in the first row. And then here we have 0. In row 2, we'll be multiplying 2 to each value. So 2 times 0 is 0. 2 times 1 is 2. 2 times minus half is minus 1. And 2 times 3 minus 3/2 is minus 3. And here we have minus 1 again. So here we have 0, 0, minus 9, minus 9, and minus 5. So now we have got in the reduced row echelon form our matrix, augmented matrix, or you can say that the upper triangular matrix. So now we'll use the augmented matrix, or we can copy it from here and do it on the other page. Okay, so we'll rewrite the augmented matrix in terms of linear equations now. So if you write this as linear equations, we would write it as here now as, so we have for the first one all ones, that would be x1, 1x1, so that's x1, plus we have x2 plus x3 plus x4 is equal to 1. For the second row here we have 0x1, so I will not write that. And then we have 2x2, so here we have 2x2. And then we have minus 1 times x3, so you have minus x3. And then minus 3 times x4, so that's minus 3 times x4 is equal to minus 1. And then we have here no value for x1 and x2, but we have minus 9 times x3. So here we have minus 9 times x3, and again minus 9 times x4 is equal to minus 5. So those are the linear equations for the augmented matrix, or the last augmented matrix that we got. So now here, what you need to understand is that if there is a point that if we have a point that is A1, A2, A3, A4, and this point is a solution for the first linear system here, the linear equations. If A1, A2, A3, A4 is a solution to this system here, then it is also a solution to this system here. So what we can say is that, so if, okay, so I hope that part is clear. So if this is a solution to the original system, it is also a solution to the last augmented matrix here. And the equation that we have here is equation 3, which is, let me write it down here. So maybe I'll erase this part. Okay. So the equation minus 9x cubed minus 9x to the power, x4 is equal to minus 5. This equation implies that, let me write it down. This equation implies that either x3 or x4 can be chosen. Can be chosen free if for some real number R we have x4 is equal to R. Then we will have minus 9 times x3 minus 9 times, instead of x4 we're replacing it with R. So here we'll have here R, and that will be equal to minus 5. So R is x4. Okay, so let me clear this again. So for the last equation here, that's equation 3, that's minus 9x3 minus 9x4 is equal to minus 5. This implies that either x3 or x4 can be chosen freely. And for some real number R, then the equation will look like this. How I wrote it down, that's minus x cubed, x3 minus 9. Instead of x4, I've replaced it with R. You could also do the other way around. Instead of choosing x4 as R, you could choose x3 as R. It's anything you can choose and you will arrive at the right solution. So it will be the same thing. So here we're choosing, as we can choose any either of x3 and x4 freely. And what we choose for this part here is that x4 is equal to R, which is any real number. So here, if we write the equation here like this, so this is, okay, so this implies that x3, now making x3 the subject of the formula, we'll have here x3 is equal to, so here we have minus 5 already, and that will be added. So minus 9R will go on the other side and it becomes plus 9R. And here you have it, x3 minus 9, that will go and divide the whole thing. So here you have minus 9. And this is equal to, if we solve it, it's 5 over 9 minus r. So that's what is x3 equal to. That's what is x3 equal to here. Okay. So x3 is equal to 5 divided by 9 minus any real number. Now, the next equation that we have, which is 2x2 minus x3 minus 3x4 is equal to minus 1. This implies that if you replace now the value of x3 and x4 that we already have, so x3 will take from here, which is 5 over 9 minus r. So here you'll have now 2 times x2 minus 5 over 9 minus r. Use brackets because if you have subtraction sign in front, it changes the sign inside. So here you have 5 over 9 minus r minus 3 times x4, and we have said that x4 is equal to r here. So that's equal to minus 1. So let me write that again. So this here is equal to, is actually x3, and this here is x4. Okay, so that would be equal to, so here now if you make x2 the subject of the formula, you will have here on the other side minus 1. Then you have, if 5 divided by 9 minus r goes on the other side, you will have here plus 5 over 9 minus r. And if minus 3r goes to the other side, you have plus 3r here. So now you have with x2, you have 2 multiplying, so it will go on the other side and divide. And you could also write it as the whole thing is multiplied to 1 over 2 instead of saying divide by 2. So this, if you solve, what you get is x2 is equal to minus 2 over 9 plus r. Now, finally, we come to the third equation, which is we have x1 plus x2 plus x3 plus x4 is equal to 1. So in this one here, if you replace the values, what you get here is now, so we do not have a value for x1 as of yet. We do have a value for x2, we just found out here, which is minus have here. Okay, I hope I didn't make any mistake here. Okay, so now, okay, instead of writing it down, maybe I could directly make x1 the subject of the formula and show it to you. So let me write it in the other way around. So this would imply that if we want to make now x1 the subject of the formula, it would be 1 minus the x2 from here. When it goes that side, it becomes minus x2. And the x3, it's positive this side, so when we go on the other side, it will be minus x3. And so for x4, you have minus x4. So now if we already have x1 as a subject, and then we don't need to worry about numbers later on. We did it at first. So here we have 1 minus x2, and the value for x2 is minus 2 over 9 plus r. Then we have minus x3. So x3, you can see it from here, or you could go to the other page and see again. So here we have for x3, 5 over 9 minus r. And then we have for x4, r. And that is equal to 2 over 3 minus r here. So that's the value for x1. Now we got value for x1, x2, x3, and x4. So let's write those down. For any real number r, for any real number r, we have, we have that substituting the numbers x1, which is x1, that's equal to 2 over 3 minus r, x2 minus 2 over 9 plus r, x3 5 over 9 minus r, x4 is equal to r. So for any real number r, we have that substituting the numbers x1 as 2 divided by 3 minus r, and x2 as it is, x3, x4. In the given system that we have, each linear equation is then satisfied. So the following points make up the set of solutions for the given system of linear equations for each r that is a member of the real numbers. So any real number which is r, if put into this point here, will be a solution for the linear system that we are solving in this question here. So now let's go and see what's our second part of the question. It is find 3 different points that are solutions to the system and check whether your second point is indeed a solution of the given system of equations. So here we just told that if we take any real number r and we insert it into this point here, then what we get here is a solution to our linear system of equations here. So let's go ahead and choose different values of r because we have to give 3 solutions for this system. So that's part 2 or part B, you can say. So we need to now find out 3 different points that are solutions of the system, right? So for the first one, let's say we choose the value r is equal to 0. It is a real number, yes. Then, if r is equal to 0, Then for x1, the value will be, it's 2 over 3 minus r, so r is 0, so minus 0 will be the same number, the number 2 over 3. And for x2, the value is minus 2 over 9. For x3, the value is 5 over 9. And for x4, the value is r itself, so that's 0. So the point is x1, that's 2 over 3, x2, which is minus 2 over 9, x3, that's 5 over 9, and x4. And this is a solution of the given system. So now let's go ahead and find out the next point. So for this part here, I'll choose the value for r is equal to 1. In that case, our point will be, let me find it out maybe, or maybe I'll just write it in the same format here. So if r is equal to 1, then we have x1 is equal to 2 over 3 minus r, that's 1. And that gives us the number minus 1 over 3. x2 is minus 2 over 9 plus 1, or r, which is equal to 7 over 9. And then x3 is 5 over 9 minus 1, that's minus 4 over 9. And then we have x4, that's equal to r itself, that's 1. So the point is minus 1 over 3, 7 over 9, minus 4 over 9, 1. Now, let's choose another value for r as a real number. So if we choose now r is equal to 2 over 3, then we'll have x1 is 2 over 3 minus r, that's 2 over 3. So that will be equal to 0. x2 is minus 2 over 9 plus r, which is equal to 4 over 9. And x3 is equal to 5 over 9 minus r, two over 3, and that's equal to minus 1 over 9 here, and x4 is equal to r, that's 2 over 3. So the point here will be 0, 4 over 9 minus 1 over 9 and 2 over 3. So these are all solutions to the given system here. Now, in our question, if you remember, we had here to check whether our second point is indeed a solution of the given system of equations. So now we have to check whether our second point here is indeed a solution to the given system of equations. So let's go ahead and work on that now. So our second point is minus 1 over 3, 7 over 9, minus 4 over 9, comma 1. Now, our set of equations that we have, if I copy it, it will be easier for us to work it out. So let's take the set of equations here. Okay. So here now, instead of x1, we will be replacing it with our values. So I think I have to separate it a bit more here. Okay. So now I'm replacing the x1 here with the value here, which is, you can say 1 times minus 1 over 3. So I don't actually have to write here 1 times everything. I'll just write it in simple terms here, replacing the 1, because 1 times anything is 1 again. I mean, the number itself again. So here we'll just write the number, which is minus 1 over 3, plus we have 7 over 9, minus 4 over 9, and then we have 1. And now if you solve this, you will see that it is actually equal to 1. So that will be correct. And then here, again, I have to replace the x values. Here I just remove the 1. Okay, so for x1 here, we have 3 times minus 1 over 3. And here we have 7 over 9, 4 times minus 4 over 9, and 6 times 1, and that is equal to 4. And here we have 4 times minus 1 over 3, 3 times 7 over 9, and here we have 1 as x4, and that will be equal to 2. So we have checked the values here. They're all correct. And so I haven't like detailed worked out that how is it equal to 1, 2, 1, 4, or 2, because you can just press this in the calculator and solve it easily instead of working it out by hand. So that would show you that if you solve this part here, you will get 1, and if you solve this part here, you get a 4, and if you solve this part here, you get a 2. So then now you can say that since the point minus 1 over 3, 7 over 9, minus 4 over 9, 1 satisfies each equation, this point is indeed a solution of this system of linear equations. And that's the end of our tutorial today.